Good morning, everyone. Um, so this is a pleasure for Anne and me to have the opportunity to present you today the KBR Data Science Lab, which is our new challenge within the cooperation between the VUB and KBR. So briefly, I will tell you some words concerning the context. At KBR, from 2017 up to this year, we are living a very important period concerning the digital transformation. This is, of course, not an exception. This is a major trend in the world for libraries in general, national and heritage libraries in particular. Um, but for the first time in the history of the KBR, it has been officially decided that the strategy would be focused on digital, so that every development within the libraries, main activities within the libraries would contribute to the digital transformation. So with the keyword digital first. And the ADOX project took place within this, was already started before we took this, we adopted this strategy. But of course, the ADOX project gave a strong contribution to the setup of this strategy. And what do we mean when concerning digitization? When we say digital first, it means that the focus on our activities um, would have to increase the digitization efforts and to systematize to multiply opportunities and activities to invest also to be able to increase the percentage of the digitized collections which could be available online. So the online accessibility and the digitization would become more than before a priority. That's a very important part of the strategy, but that was not enough. Secondly, a very important aspect of this strategy is developing activities, making research to facilitating research in the humanities, so that activities inside the libraries would contribute to the development of methodologies, practices, and tools for facilitating the research, external research made based on our collections. And based on that strategy, there are two levels of actions which are very important here when we are speaking about data science, the data science lab, is that we have the opportunity to increase and to set up and to increase research and development thanks to research projects and several federal programs like BRAIN and FETWIN. So getting money for making research, but also getting money to increase partnerships, to increase and to structure collaboration, cooperation between the library and universities, or between universities and the library. And the idea is that based on funded on projects at the library, we now are able to increase the dynamic related to research and development on the digital field in digital humanities. And when some developments make sense and are enough in quality to become a structural development, they would become they would be implemented for operations. This is why we are making a lot of investment in equipment this year, purchasing of robot scanning, so that we are evolving to the robotization of the digitization, but also many other technical developments to be able to highlight digital collections from which are completely remaining unlocked today. And so on the next slide, please. This is within this context that we set up, Anne Domes and myself, the KBR Data Science Lab, a continuation of the ADOX project concerning the collaboration between VUB, the DIMA, the Digital Mathematics Department, and KBR, based on the Digitization Research and Development Department, with the main goal, and Anne will highlight you and more and better explain the concretization of this main goal. But the main goal of this data science lab will be the development of applications that increase the value of the digitized and born digital collections in the cultural heritage sector, and is using data and model-driven AI, machine learning. In particular, the lab aims on the one hand to improve automate digitization workflow, and on the other hand, developing innovative library services. Anne, I give you the floor.
Thank you, Friedrich. You might wonder what the mathematician is doing in this context. And actually, the relation is this painting that I like to use as a metaphor, the painting of René Magritte, telling us that a painting of a pipe is not a real pipe. Well, we as mathematicians, we work with digital images, which are representations of objects, but then in pixels. Now, if we have pixels, then we have to think about what that means for a computer. Well, for a computer, every pixel actually has a color meaning, and that color is given to him in numbers. So a digital picture and its pixels can actually be loaded into, for example, Excel. So you can make a very big Excel file where you have numbers representing those colors. Now, we'll zoom in a little bit. When we have low numbers, like for example 0, it means we have black. And when we have very high numbers going up to 255, we go into the whiter region. So that's why you actually start to see the structure of the pipe in that Excel. Now, once we have translated an image into a big array of numbers, then the mathematician comes in. Because using mathematics and computations on those numbers, we can actually start to investigate what is on that picture, what type of information can we extract. And this is where our job begins. We're not actually doing the computations by hand, of course, because that's what our computer does, but we're telling him what computations he should do to extract the information. And actually, one of the first ones that was able to extract information from digital pictures was this guy, Ray Kurzweil, who developed in 1974 his so-called reading machine. This was a machine for the visually impaired, where you could put on a book and it would scan, take a picture of that book, and read out loud the text which is present on the pages. He's the one that actually started the OCR or optical character recognition software business, and also the start of flatbed scanners in order to turn books into images. Now, for him, those scans were black and white, so letters were actually translated in an array of numbers with zeros and ones, and he could use patterns in those zeros and ones to recognize characters. So this was already mid-70s, but it was until the 90s before this really became a commercial product. Now, there were still some issues with it when you would start to scan more older manuscripts or have low quality scans, because then OCR software will recognize in these words things which make no sense. And you've all known these or got into contact with these things, CAPTCHAs. CAPTCHAs were actually set up to help humans help translate things which OCR software got messed up with. So people would type words, and this would help to transform digital images of old books into machine-readable text. And this was one of the bases for the Google Book project that Tan referred to. Now, in the meanwhile, developments within AI and computer vision have significantly improved this character recognition. But when we are dealing with scans of pages which are disrupted and have holes, like this very old newspaper from the library, or which also have complex layouts, it's very difficult for OCR software to make sense of that. It could recognize the characters, but it could put them on one line, and then everything gets messed up. And especially when you have holes, it doesn't know what to do with it. While again, we as humans can easily read through those holes. And this brings us to the technology that Tan spoke about in the first session of today. And by using the way, or translating the way that we look at text, we are able to recognize the layout and improve text recognition of old pages. Now you also see some pictures here, and that brings me to the next part that we will do within the data science lab. Because from here, of course, together with the work that Anne has been doing and other work that we find internationally on extracting information from data, there is still a lot of information that can be extracted from pictures and images present in manuscripts. And in the future, we will use technology that we developed within our lab to investigate paintings, as Nico already introduced. We indeed were able to work on this Starry Night, another famous painting of Van Gogh. And we were able to create mathematical transformations that are able to translate this painting into numbers that represent the Van Gogh painting style. And from this, we could actually distinguish fake from real Van Goghs. So we can capture the structure of paintings and objects on photos with mathematical computations. And this, for example, could be put into place to study the very nice collection of the Duke of Burgundy's that we have in the KBR, where you have a lot of, for example, animals appearing within those texts, and rabbits are one of those that are frequently appearing and that have different meanings. Now we can combine the recognition of where are rabbits, what type of rabbits, what is similarity, with the information that is around that rabbit in order to study iconography and to get more out of what could be meant with certain images of those rabbits and other nice drawings. So this was in a very quick nutshell what we plan to do on combining text information, visual information, in order to help us discover the vast knowledge that is hidden in our manuscripts. Thank you.